So the northern Indian Ocean is a funny beast. It has contrasting warmings happening over the Arabian Sea and the Bay of Bengal. As we know, everything over the Indian Ocean is very seasonal. So you have intermonsoon seasons and the monsoon seasons, southwest, northeast, summer, winter, and then you have spring intermonsoon and fall intermonsoon. Bay of Bengal is a warm ocean, so if you try to warm it, it tends to convect more and get rid of the energy, whereas the Arabian Sea still has room to warm, and it seems to be connected to this rapid warming happening here, as a couple of papers have shown already. And then there is the issue of the cyclones. So the number of cyclones here is not increasing as much as it is increasing here, and then there are issues of whether they are happening more often very close to the monsoon onset, whether that is related to the change in wind stress or vertical shear that is influenced by the Arctic warming and so on and so forth. So in that context, there is this new paper that says there is a zonal seesaw variation of tropical cyclogenesis over the Arabian Sea and Bay of Bengal, South China Sea. So they find that these two are kind of clustered together, and this one is acting as a separate one. And then they talk about the potential forcing coming from what was initially what has been called the Indo-Pacific tripole. So if you look at El Nino, typically you have warming here, you have cooling here, and warming here, and vice versa for La Nina. So looking at that, let's read the key points, the abstract, and the summary given for general public as it may. Key points: a zonal seesaw variation of tropical cyclogenesis is detected between the Arabian Sea and the Bay of Bengal, South China Sea. So they call it BOBSCS, which are typically the acronyms. The tripole SST anomalies over the tropical Indian and Pacific Oceans play a crucial role in the zonal seesaw variations of TC genesis. Numerical experiments show a critical role of SST anomalies in the Western Indian Ocean in the dipole pattern of vertical motion. So we'll see the SST pattern, and then they take that pattern, they force a model and argue that the model can reproduce this vertical velocity pattern in the pressure coordinate. The variation of tropical cyclone formation over the North Indian Ocean and South China Sea during the post-monsoon season is explored during 1979 to 2020. So it's important to keep this season in mind, because there is a pre-monsoon cyclone season and a post-monsoon cyclone season over the Indian Ocean, where the South China Sea has a typhoon season that kind of runs pretty much through the year, in fact. And now I'm watching this year, for the first time I'm seeing that there are many cyclones playing out in the Pacific, and they seem to have a very direct interference with monsoonal circulation, which may be another good topic for research that somebody will hopefully take up. Okay, so a zonal seesaw variation of TC genesis is detected between the Arabian Sea and the Bay of Bengal SCS, so Bob SCS for brevity. More TCs or less TCs over the Arabian Sea tend to occur with fewer or more TCs over the Bob SCS. So I hate these kind of wordings, but basically when there are more TC genesis on the Arabian Sea, it's somewhat suppressed over the Bob SCS, and vice versa. That's why it's a seesaw. Analysis of both observations and coupled model intercomparison project phase 6 output show that tripole sea surface temperature anomalies in the tropical Indian and Pacific Oceans play a crucial role in the zonal seesaw variation of TC genesis. Positive Western Indian Ocean and tropical Central and Eastern Pacific Ocean SST anomalies and negative Western Pacific SST anomalies induce anomalous ascending and descending motions and high and low humidity transportations to the middle troposphere over the Arabian Sea and Bob SCS respectively. So when you think about cyclone genesis or cyclogenesis, vertical shear, mid-tropospheric moisture loading, sea surface temperature, hurricane potential, vorticity, and so on are considered as parameters. Meantime, anticyclonic vorticity anomalies appear over the in the Bob SCS region, and negative anomalies of vertical wind shear are induced over the NIO and SCS. So vertical shear is very critical. The combined positive contributions of upward motion, mid-level humidity increase, and low vertical wind shear favor higher TC genesis over the Arabian Sea, whereas the joint negative effects of downward motion, mid-level water vapor decrease, and lower level anticyclonic vorticity anomalies result in less TC genesis over the Bob SCS. Numerical experiments show a critical role of the WISST anomalies in the dipole pattern of vertical motion, which is crucial for the zonal dipole variation of TC genesis. Presumably the vertical motion is critical for the moisture supply, which is a critical component of the TC genesis. So I'll just run through some results, and then before going there we'll read the plain language summary as well. Although the tropical cyclones frequency number that form over the South China Sea, Bay of Bengal and the Arabian Sea are relatively small, these regions are densely populated, which means that the impacts of TCs can be significant and widespread. The study presents observational and modeling evidence for a seesaw variation of tropical cyclone genesis between the AS and BOBSCS during the post-monsoon season, so that's September to December. Composite analysis display that the zonal seesaw connection of tropical cyclone genesis frequency over the Arabian Sea and Bob SCS is closely linked to the zonal tripole distribution of the SST anomalies over the tropics of the Indian and Pacific Oceans, which exert a significant influence on the vertical zonal overturning circulation and the environmental parameters for TC formation over the Arabian Sea and the Bob SCS. We conducted evaluation of 19 CMIP6 AMIP, so those are coupled models and forced models. So they examined these simulations and revealed that 53% models were able to successfully simulate the zonal tripole pattern of TC related variables between AS and Bob SCS. Okay, so 26% of the AMIP and 53% of the CMIP, I suspect. The present findings may have potential to enhance the seasonal prediction for tropical cyclone genesis over the SCS, AS and BOB regions. That is always said, but it's unclear how you would go from there to the predictions, even though if you know that Western Indian Ocean SSTs are critical, then you can use that to presumably make sure you are getting the right pattern of cyclone genesis. So here this figure is basically, the temporal variation of TC genesis frequency in the September, October, November, December, the season from 1979 to 2020 in Arabian Sea, BOB, SCS and BOB, SCS. The red crosses in A to C, we will see next in the next panel, represent selected more ASTC genesis and less BOB, SCS TC genesis years. The purple crosses in A to C represent the less ASTC genesis and more BOBSCS TC genesis years. The composite TC genesis number generated over the AS BOBSCS in SOND are shown with black dots during AS more BOB less years and during AS less BOBSCS more years. The digit numbers denote the TC genesis frequency within the boxed region, which we'll see. The red and blue boxes denote region of AS and BOBSCS respectively. So here we are, Arabian Sea, BOBSCS. So you can see the numbers. There's 26 here and 40 in this combined. There's 5 here, and this more than doubled from 40 to 93. So this is for the 1979 to 2020, whatever the read. Yeah. So you go back and look at yes, 1979 to 2020. Sorry about that. So here's the Arabian Sea. You have more and less years here and less and more years. So you can see that there is a slight out of phase relation, and the TC, this is TC number, and this is for Arabian Sea, Bay of Bengal, and this is South China Sea. So Bay of Bengal and South China Sea are in phase, and you can combine them and see the numbers here. And that is the crux of the result, that there is a seesaw in cyclogenesis between the Arabian Sea and BOB and SCS combined. What are the mechanisms? So let's look at some dynamic spatial distribution and principal component of the first EOF mode of SOND OLR, outgoing long wave radiation over the NIO SCS during this period of 1979 to 2020. And it shows you that when it is not convecting here, it's convecting here. If you remember, positive OLR means suppressed convection, negative OLR as an anomaly means enhanced convection, but of course this is an EOF, so the sign is determined by the multiplication of the PC and the sign of the spatial loading, so I have to be careful. Nonetheless, you see the seesaw here, and you see that there are years when this is positive, so positive, positive, and this is negative, so less here, more here, more here, less here, and so on. Okay, so anomalies of the 850 hectopascal horizontal winds, 200 hectopascal horizontal winds, 500 HP vertical velocity in the pressure coordinate or the omega, and 700 hectopascal specific humidity, which is a prereq for cyclones to grow. And this is done during SOND, calculated by regressing on the normalized SOND AS Bob SCS TC index from 1979 to 2020. The red and blue boxes correspond to the regions of Arabian Sea and Bob SCS respectively. So you see these. The orange and blue shading and solid and dashed lines indicate that the anomalies are statistically significant at 95% confidence level respectively. So you can see that there is a relation, out of phase relation. So if you look at vectors at the boundary layer about 850 hectopascal, you have easterlies here and basically northerlies over here. This is at 200 hectopascal. Typically there are westerlies here, and there are anticyclones. So this is a cyclone, and this is both are cyclones. Okay, so this is the omega, so when it's positive here tends to be negative here, and this is humidity loading at 700 hectopascal, so negative here, positive here and negative here. So corresponding to positive moisture loading, you have the wind patterns, and you have, remember, omega is negative in the pressure coordinate, so this means vertical motion, moisture loading, reduced vertical motion, reduced moisture loading, so there is corresponding wind signals as well. Okay, so there is a broad anticyclone here, and there is a broad cyclone here. That's what is being referred to. Okay, this is same as figure 3 except for anomalies of OLR, 200 to 800 hectopascal vertical shear, stream function at 850 hectopascal, 200 hectopascal velocity potential, SST, 10 meter winds, and ocean heat content between 0 and 100 meters during SOND. Only 10 meter winds that are significant at 95% confidence levels are shown in 4E, which is this one. Again, what we saw before in the EOF and so on. So OLR out of phase, this is the UVWS, so that's the averaged vertical shear. So vertical shear in zonal and meridional velocities. So you can see this is not as clear an east-west pattern, but you can see still Arabian Sea has basically increased vertical shear when you have favorable vertical shear over the BOB and SCS. You can see whether that makes sense for you in terms of relating it, but obviously there will be a shift in the various quantities. This is the stream function, at 850, and this is the velocity potential. This is the SST showing slightly out of phase, cooling, warming. So this is argued to be important for driving the whole thing. And you have the anticyclone sitting here when you have warm SSTs. Basically, you have to look at the background winds and see whether these winds are corresponding to vertical shear and vertical velocity that is favorable for TC genesis in one place versus the other. This is the ocean heat content, which is again out of phase. So there are slight shifts. The boxes are rather large and the quantities within them are not always at the center. Some of them are at the center, some are not. So this is usually what happens. This is similar to figure 3, but anomalies of genesis potential index for SOND, and again you can see approximately out of phase. These are negative, this is positive, and it should be vice versa. Okay, so this is similar to figure 3, but for anomalies of sea surface temperature during SOND, and this is the tripole pattern. So here is a El Nino like warming, and during El Nino you will have negative anomalies here with this horseshoe pattern, which is well known, presumably related to the Rossby waves and so on, and you have subsidence and warming over here. Ascent and warming. So you have anomalous descent, anomalous ascent, anomalous ascent. Okay, that's the typical El Nino pattern. So here we are looking at normalized time series of AS, BOB, SCS difference index. So SST of the tripole and the TC differences are highly correlated, which is the argument that Western Indian Ocean warming as a part of this tripole. So it's not just El Nino, that's the main point. And this is, I think, a very important result. And I personally feel this tripole index, defined originally by Dak Chen, is Dake Chen as he's called, is not used as much as it should be, but this paper does use it. Finally, coming closer, these are positive years and negative years. So this is the composite TC genesis numbers generated over the Arabian Sea and BOBSCS during SOND, are shown with black dots during positive index years and here during negative index years. So tripole index positive has more cyclones over the Arabian Sea and fewer over BOBSCS, and vice versa. Much larger number here than here in the negative phase. Okay, does that convince you? Well, there are more details here in terms of what happens in divergent winds and the associated. So this is at 850 and 200 hectopascal. This is velocity potential showing the divergent winds, and this is showing you the longitudinal perturbations to the Walker cell. So you have subsidence over the maritime continent, ascent over Western Indian Ocean, and ascent over Eastern Tropical Pacific Ocean. They basically take these patterns and then put it under the atmospheric model and show that indeed they can reproduce the results, to argue that the tripole SST pattern is important for this cyclone genesis seesaw between the Arabian Sea and Bob SCS. This is the same thing. I won't go more. This is about moisture advection and horizontal and vertical advection. So moisture loading out of phase is clearly seen here. These are composite differences of genesis potential, again out of phase relations. They also look at other indices, relative humidity. This is, so let's go. GPI is here. This is the absolute vorticity, relative humidity at 700 HPA. This is the vertical pressure velocity at 500 HPA. This is the vertical shear between 200 and 850, again approximately weaker here, stronger here, and should be vice versa based on the phasing. And this is the potential intensity between positive and negative years of SOND. So that is kind of a short summary I'm convinced that there is in fact a seesaw there. The key question then is whether this seesaw started only after 1979, and whether not averaging over 1979 would mean that there is some sort of a regime shift. For example, this is a time series here. If you look at this one, because there is a paper coming out that argues that there is some sort of a regime shift that happened around 1997, which has been noted in many different quantities, including SSTs. So do you see any shift happening here? Maybe not. But whether this is related in any way to Arabian Sea warming, which has been prominent more recently, or whether this also existed before 1979 is not clear, because these people are not really arguing for any kind of trend or global warming as yet. The tripole is mostly a natural mode of variability associated with El Nino, and there are times when it's not a tripole, like this year in 2023. If you look in June, July, the entire tropical Pacific is warm, and there is a paper in 2012 by Ashok Karamuri, and I was a co-author, which shows that maybe that kind of a pattern where the entire tropical Pacific is warm is related to superposition of El Nino and global warming. So it's not clear how that would fit into the story of the tripole and the seesaw in cyclones, but that will be for another day, or maybe these authors will come back and discuss that in the future in some other paper. Okay.